Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today we are studying probability. Let us have another way of proving probability of event plus probability of not event is equal to unity. We just showed you in the previous video that how we proved this is equal to 1 by some examples. Now let us have a general proof for this theorem, that probability of event plus probability of not event is always equal to 1. Now let us have the proof, the simple proof. Let a random experiment, let us consider a random experiment. Let a random experiment has, now since it's a random experiment, there must be number of sample points in the sample space of the experiment. So let us say, let a random experiment has n number of outcomes. Let a random experiment has n number of outcomes, out of which let us say m are favorable. We just learnt yesterday that there are favorable number of outcomes and there are total number of outcomes. The probability is the number of favorable outcome to the total number of outcomes. We denote that by probability of E is equal to number of E divided by number of S. Let a random experiment has n number of outcomes, out of which m are favorable. We have learnt that probability of event is number of event divided by number of sample space. That means there are some number of outcomes in the event and the total number of outcomes in the sample space. Having said that, let us say a random experiment has n number of outcomes, out of which m are favorable. Therefore, number of not favorable outcomes. Let me show you one example before this. We will understand this in a better way. For example, my sample space is on throwing a die. Let us say a random experiment is throwing a die. So the sample space is 1, 2, 3, 4, 5, 6. This is a sample space. Now let us say favorable outcome is prime number. So 2, 3, 5. Now pay attention. Therefore, number of E is what? What is the number of favorable outcome? That is 1, 2, 3. Because there are 3 sample points in E. So we have 3. Now what is number of, which implies that number of not E? What is the number of not favorable outcomes? Not favorable outcome means 1, 4 and 6. These are not favorable outcomes. Though the number of not favorable outcome is also 3. Why? Because it's total number of outcomes minus number of favorable outcomes. Let me give you one more example. For same sample space, let us say for same sample space. Now let us say my event is number greater than 4. Number greater than 4 is 5 and 6. So number of favorable outcome, what is the number? 2. What is the number of not favorable outcomes? 1, 2, 3, 4. How many are there? 4. How will get the 4? 6. The total minus the number of favorable outcome. So total number of outcome is 6 minus the favorable outcome, that is 2, and 6 minus 2 will give you 4. So as here, if the random experiment has n number of outcomes, out of which m are favorable. Now favorable outcomes are, number of favorable outcome is m. Therefore, number of not favorable outcomes is equal to total minus favorable. That means n minus m. Very simple. Number of not favorable outcomes is equal to n minus m. Now see, we know the formula. Then probability of event. Now if I find probability of event, you know it's number of event divided by number of sample space. Got it? Now number of event means number of favorable outcomes. Number of favorable outcome is n. Sorry, n is total number of outcomes. M is the favorable outcome. So m divided by n of sample space. Total number of outcomes. N is the total number of outcome. So my probability of event is m divided by n. And if I find probability of not event is number of not event divided by number of sample space. Number of not event means number of not favorable outcomes. Number of not favorable outcome is n minus m. Divided by number of sample space means total number of outcomes, and total number of outcomes is n. So we have probability of event m by n, probability of not event n minus m by n. Therefore, probability of event. Let me do the addition of these two. Probability of event plus probability of not event. Let me find the addition of probability of event plus probability of not event. Now probability of event is m by n, then plus probability of not event, that is equal to n minus m by n. Now on solving this, what I'll get? The common denominator, so I'll get m plus n minus m divided by n. Got it? Common denominator, so m plus n minus n. Now m minus m is 0, so it gets cancelled. We are left with n divided by n. N divided by n is nothing but 1. So we proved that probability of event plus probability of not event is equal to 1. What we were required to prove, probability of event plus probability of not event is equal to 1. Hence, proved, then quod erat demonstrandum. So this was the proof for this theorem, that probability of event plus probability of not event is equal to 1. Make a note. Let us understand one more law, that is called De Morgan's law. De Morgan's law. De Morgan's law says that if you do, it is in two forms. Number one, if you do A union B whole complement, that will always be equal to A complement intersection B complement. A union B whole complement is equal to A complement intersection B complement. Or another form of this is the opposite of this. That means A intersection B whole complement is always equal to A complement union B complement. This law or this equality, this is called De Morgan's law. Now let us prove this De Morgan's law. To prove, so we are going to prove, let us see how this is possible. Let us have a general idea for that, general proof. You can also prove this by having some examples of sets, like take some set A and B, then you can prove that you can substitute the values in. But let me show you the general way of proving this De Morgan's law. A union B is equal to A union B whole complement is equal to A complement intersection B complement. Now this and this is same. When we prove this, similarly we can prove this thing. Now let us understand. You know union is the combination of A and B, An intersection is those elements which are present in both A and B. For example, if I have set A is the set of all 1, 2, 3. If I have A this, if I have B is the set of all 2, 3, 4. Now these are my two sets. If A contains 1, 2, 3, B contains 2, 3, 4. Now if I do A union B means all the elements of A and B are present in A union B. That means it's 1, 2, 3, 2, 3, 4. But repetition, we write it once. That means 1, 2, there are two 2's, so I'll write it once, 2 3's, write it once, then 1, 2, 3, 4. So this is called the union. Now if I find intersection, A intersection B, A intersection B means whatever the element which is common in both the sets. Which is common? 2 is common, 3 is common. Yes? So intersection has 2 and 3. So technically union means which is present either in A or in B, and intersection means which is present in A and in B. So this is point 1. Then I have one more thing, that is A complement. A complement means those elements which are not present in A but present in the universal set, because for every set we have some universal set. Let us say here our universal set is, let us say, natural numbers 1, 2, 3, 4, so on and so forth. All the natural numbers are the universal set. Now A complement is, except the elements of A, all the elements of U are present in A complement. That means U minus A. All the elements of U except for the elements of A. Similarly, if I find B complement means U minus B. All the elements of U except for the elements of B. So that is the complement. Now let us pay attention here. A union B whole complement is equal to A complement intersection B complement. Let us see the proof. Let X be any element. Let X be any arbitrary means any random element. Let X be any arbitrary element such that X belongs to A union B whole complement. That means, let us say some element, say X belongs here in A union B whole complement, because A union B whole complement is a set. So there are some elements in this set. Let us say X is one of the elements which belongs to A union B whole complement. Got it? Which implies that. That means if X is contained in A union B whole complement, it is not contained in A union B, because complement means the opposite. Like we had, complement is not event. If I have set A 1, 2, 3, A complement means the elements present in A complement are not present in A. Got it? So that means if X belongs to A union B whole complement, X does not belong to A union B. Since it is in A union B complement, that means it's not in A union B. If it is in A complement, it's not in A. If it is in B complement, it's not in B. If it is in C complement, it's not in C. So on and so forth. If it is in A union B complement, it's not in A union B. So simple. Okay. Now it is not in A union B. When element is not in A union B, that means it's neither in A nor in B. Because we just learned that A union B is the elements either of A or B, just this. Either of A or B, that is the A union B. Now, X does not belong to A union B. I repeat, X belongs to A union B complement. That means X does not belong to A union B. Now we are here. X is not belonging in A union B. That means it will be neither in A nor in B. Because had it been the case, it would have been in the union. If it is in A or B, it would surely have been in the union. So that means it's neither in A nor in B, which implies that X does not belong to A and X does not belong to B. Got it? Which implies that now X does not belong to A. It does not belong to B either. That means X does not belong to A intersection B. And rule means follow this. I told you and rule, and is intersection and or is union. And is intersection or is union. X does not belong to A intersection B. Why? X does not belong to A. First of all, write this thing. X does not belong to A and X does not belong to B. Now, if X is not present in A, that means it is present in A complement. Write like this. And X is not present in B. That means X is present in B complement. I just told you this. X belongs to A complement and X belongs to B complement. Now, X is present in both A complement as well as B complement. And so that means I can say X belongs to A complement intersection B complement. Got it? Since X belongs to A complement as well as X belongs to B complement, that means it's present in the intersection of A complement and B complement. So X belongs to A complement intersection B complement. Now let us call this as second. Now you started with X. X is element which is present in A union B whole complement. Now after going through this, it is also present in A complement intersection B complement. That means this set is the subset of this set, because every element, if this is true for X, it is true for any element you start with. So that means from first and second, we get A union B whole complement is the subset, this is a symbol for is the subset. A union B whole complement is the subset of A complement intersection B complement. Got it? Now let us say, let us name it, let us call it third. Call it? Now, let Y be an arbitrary element. Now let Y be any arbitrary element such that, now let Y be any arbitrary element. Whatsoever we did with X, let us do the same thing with Y. Let Y be any arbitrary element such that Y belongs to, now let us say Y belongs to this thing. Y belongs to, we started with X belongs to left hand side. Now start with Y belongs to, now let us see element present in the right hand side, what will happen with that. Now let us say Y belongs to A complement intersection B complement. Y belongs to A complement intersection B complement, which implies that, now it means if Y is present in A complement intersection B complement, that means Y is present in A complement and Y also belongs to B complement. That's why it is present in A complement intersection B complement. So Y belongs to A complement and Y belongs to B complement, which implies that if Y belongs to A complement, that means it does not belong to A. I just told you this. And Y belongs to B complement, that means it does not belong to B. Okay. Now if Y does not belong to A, does not belong to B, that means it does not belong to A intersection B either. Got it? Oh, sorry, union. Y does not belong to A, Y does not belong to B. Neither it is in A nor is it in B. That means it's not in the union. So Y does not belong to union. Now if it does not belong to A union B, it does belong to A union B whole complement. Y does belong to A union B whole complement. Because it is in the set, it is not in the set, that means it will be in the complement of the set. So A union B whole complement. Now call this as fourth, call this as fifth. Now what you got from 4th and 5? From 4 and 5 we get, again the same reason, you started with Y, it belongs in this. Now after going through this, it also belongs to, that means this is a subset of this. A complement intersection B complement is the subset of A union B whole complement. Now let us name this as 6. Name this as 6. Now let us compare this third and sixth. From third and sixth we get. Now compare this and this. Now understand carefully. Here A union B whole complement is the subset of A complement intersection B complement. That means all the elements of this set are present in this set. Here it is the opposite. This set is the subset of this. That means all the elements of this are contained in this. Now all elements, when I say A is a subset of B, B is a subset of A, what does that mean? That means all the elements of A are contained in B, all the elements of B are contained in A. Here all the elements of A contained in B, and in this all the elements of B are contained in A. That means A is equal to B. Because it's not possible otherwise. A is the set of all 1, 2 for example. B is the set of all 1, 2. Now A is the subset of B because all the elements of A 1, 2 are present in B. Yes. Now for this, all the elements of B are present in A 1, 2 are present in B. So that means it is equal set. If I write here extra 3, now when I say all the elements of B are contained in A, no, because 3 is not contained in A. So this is possible only if A is equal to B. So from this and this, what you got? This is a subset of this and this is a subset of this. That means these are equal sets. From third and fourth we get A union B whole complement is equal to A complement intersection B complement, and this proves your result. A union B whole complement is equal to A complement intersection B complement. Hence proved. Got it? Now similarly you can prove this thing. It is exactly same thing. Make a note. Now the next topic is, now let us see the axiomatic approach. Axiomatic approach to probability. Axiomatic approach of probability. There are three approaches to probability. Probability. There are three approaches. Three approaches means there are three ways by which you can study probability. Number one is called classical approach. Classical approach. Number two is called statistical approach. Statistical approach. And number three is called axiomatic approach. Axiomatic approach. These are three approaches by which you can study probability. Now let us have a brief idea about all these three. Classical approach means where you study probability in a crude way. To study probability in a crude way. What does that mean? For example, you need to toss a coin 200 times. You need to toss a coin 200 times. You just go 200 times in a crude way. Toss the coin 200 times. And now if the number is 2000, now toss the coin 2000 times and see the outcome, study the outcome and get the probability. That is called the classical approach, in which you do your job in a crude way. You do the probability literally. You do the experiments literally. That is called the classical approach. After that, we have statistical approach. Statistical approach means you understand some formula, get the graphs of the experiment. Now, understanding probability with the help of graphs, that is called the statistical approach. By studying the statistics, like if someone has tossed it 200 times, some other one has tossed it, say, some 1000 times. Now you are studying the statistics, you are seeing the statistics, and you are considering the statistics, and you are considering the graphs. By that way, if you are studying probability, that approach is called the statistical approach. Now after that, the final one is axiomatic approach, and our topic is that axiomatic approach to probability. Now let us see axiomatic approach. Axiomatic approach means to study probability in a arithmetic way or in a mathematical way, by transferring the concept of probability in a mathematical interpretation. So let us see what axiomatic approach is. Remember three rules. There are three rules by which you can apply the axiomatic approach to probability. There are three rules following for this. Number one is axiomatic approach of probability says, number one rule is that probability of all elementary events, it is equal to 1. That means if I do probability of any event, say E1 plus probability of E2 plus probability of E3 plus so on and so forth, plus probability of En, this is going to be 1. What do I mean? If you have some random experiment, and for this random experiment, you have some events. Let us say you have n events. Let us say for this experiment you have n number of events, and these events, if you take elementary events, elementary event means, we studied in the terminology, elementary events means which has only one outcome present in that event, one favorable outcome. So number of events, if you have n number of events and all the events are elementary events, so that means if you add all these events, you will end up with 1. That is the first point. Number 2, if you end up with the probability of all these events, you will get 1. If you add the probability of all elementary events, that's equal to 1. So theoretically it's written like this: probability of all elementary events is a unity. Unity means 1. This is the point 1. Now point number 2 is the range of probability. Probability of event, some event, say E, probability of E is equal to 0 is less than or equal to, probability of E is such that 0 is less than or equal to, probability of E is less than or equal to 1. What does that mean? That means probability of event, any probability, it is within the range of 0 through 1. Probability of event can be 0, it can be 1, and it can be in between 0 and 1. It cannot go beyond 0 and 1. That means it cannot be equal to greater than 1, neither it can be equal to less than 0. What do I mean? Probability is never negative nor greater than 1. Let us see how. For example, we have, let us say, let probability of some event is 2. Let us say probability of some event you got 2. Which implies that now probability of event is number of event divided by number of sample space. Is it true? Yes. And it is equal to 2 because you assume that probability of some event is 2. Now probability of event is number of event divided by number of sample space, which is equal to 2. Then I can write number of event is equal to twice number of sample space. Number of event is equal to twice number of sample space. Now if you observe carefully, this is not possible. Because I am saying number of favorable event, number of favorable outcome is twice the total number of outcomes. Number of favorable outcomes are taken from the number of total outcomes. Now how is it possible that favorable outcomes are greater than the total number of outcomes? It's not possible at all. So this thing is not possible. Since this is not possible, therefore probability of event is 2 is not possible either. You got it? Similar is the case with less than 0. Let us now say probability of some event is, let us say, negative 1. Having said that, it means number of event divided by number of sample space is also negative 1. Yes. That means number of event is equal to negative times number of sample space. It is not possible either, because I mean to say that number of favorable outcomes is negative times number of, it is equal to some negative number, and negative number is not possible in this case. So not possible either. Therefore probability of event is equal to negative is not true. So that means we have to agree that probability of event lies between 0 and 1. This point is true, that probability of event is equal to 0. It can be 0 and it can be equal to 1. How? See how. Probability of 0 means it is, probability of 0 means it is dead event. Dead or impossible event. Impossible event. In case of impossible event, probability is 0. And in case of sure event, or you can say certain event, sure or certain event, in that case probability is 1. Let me give you one example. For example, you have a classroom, and in this classroom, let us say you have 100 boys. In a classroom you have 100 boys. Now if we are blindfolded and we are told that let us select a student randomly in this class, what are the chances that if I being blindfolded, what are the chances that if I point towards a student and that student happens to be a boy? Chances are 100% it's a boy, because the boy contains only 100, the class contains only 100 boys. So if I point towards any student, it is surely a boy. So that means in that case, if I find probability of my event and my event is selecting a boy. Selecting a boy means number of favorable outcome divided by number of total outcomes. Number of favorable outcome is how many are favoring me, how many students are favoring me. All 100 students are favoring me. So divided by number of sample space, total number of students. So total number of students is also 100. Now 100 divided by 100 is 1. That means this event is called sure event, because I'll surely get a boy if I point towards a student in this class. Now take another example in the same class where we have 100 boys. What are the chances that if I point towards a student, it happens to be a girl. What are the chances? No, it's not possible. I will not get a girl because there are only 100 boys. So if I do probability of event this time, now this event is choosing girl. Choosing girl. Now probability of event is number of event divided by number of sample space. Number of event means number of favorable outcomes. What is the total number of favorable outcome in my case? What favors me? No student will favor me. Because there are only boys present in the class. There is no girl. No student will favor me. Divided by total number of students, that's 100. And 0 divided by 100 is 0. So that means in this case, I got the probability of event. Probability of choosing a girl in this room is 0. And hence this event is called the dead event or impossible event because this is not possible. But we got the probability as 0 or 1. This was the second rule, that probability of event is such that 0 is less than or equal to probability of event less than or equal to 1. Now the last one is that for any event, let us say E, probability of E is equal to summation of probability of some xi, where I ranges from 1 through n, such that xi belongs to E, that event. What do I mean? For any event, let us say any event E, if you want to find the probability of that event, that is equal to summation of probability of individual elements, individual points in that E, because I said xi is some element which is ranging from 1 through, it can be x1, x2, x3, x4, xn, the number of elements, whatever the number of elements be in that event, because event is a set and it has some number of elements. Let us say those elements are x1, x2, x3, x4. Now if I do summation of those probabilities, if I find probability of x1, probability of x2, probability of x3, and then if I sum up those, summation means sum up, I sum up those individual probabilities, I'll get the probability of event, and that I said xi belongs to E, because these are all xi, all members of E. So in that case, probability of event is equal to summation of probability of individual elements. That was the number 3, and this is the axiomatic approach to probability. Hope you understand that. See you next time. May Allah bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.